Students, now let's we conduct full wave rectifier, and in the full wave rectifier we have two types. Now let's we conduct the first experiment, center tapped full wave rectifier without filter. Okay, this is a circuit diagram. Input side we are going to use AC supply for the transformer, 230 volts input, and output is 606, and we are going to use in the center tapped rectifier we are going to use two diodes and one RL. Here we are going to use without any filter circuit. Here we are not going to use any filter or capacitor or inductor. This is the expected output waveform and input waveform. This is the input waveform, this is the output waveform. Okay, now let's see the circuit diagram in the breadboard. Here I am going to connect the circuit diagram. Okay, I am going to remove the capacitor. Here the circuit is related to without capacitor, okay, without filter. Here I am going to use two diodes and one resistor. Okay, from here the transformer, middle one is 0 point, that point I am going to connect to the ground, and one of the positive terminal I am going to connect to the diode terminal, another one terminal to the diode. And now let's check the output value in the CRO. This is the expected output graph. Here the output shown 11.0 peak to peak. We need to divide it by 2, that means 5.5 V peak, because here we are going to consider only half cycle. Okay, now let's check the reading in the multimeter. Now let's check the reading in the multimeter. We need to check the reading across the diode, across the resistor, load resistor. We need to check the reading. Okay, see the multimeter shown VDC is equal to 6.28, but in the waveform here it shows 5.5 peak to peak. Okay, now it shows 10.6, like that. You consider the multimeter reading. Okay, you need to consider multimeter reading. VDC is equal to 6.28. Now let's do the calculation. VDC is 6.28. Here I am going to consider previous reading 5.94. We know the formula. We need to calculate VM. VM is equal to VDC pi, VDC into pi divided by 2, that come 9.330, and IM is equal to VM divided by RL, 9.330 divided by 1000. RL means load resistance 1 kilo ohm, is equal to 9.325 into 10 to the power of minus 3 ampere. VRMS is equal to VM divided by 2, 9.330 divided by 2 is equal to 4.66 volts. IDC is equal to 2 into IM divided by pi. It will shows 5.98364 into 10 to the power of minus 3. VAC is equal to VM divided by root 2. It will give 6.594. IAC is equal to VAC divided by RL. It will show 6.594 into 10 to the power of minus 3 ampere. Ripple factor formula, root IAC divided by IDC whole square minus 1 is equal to, you need to substitute IAC and IDC value, you will going to get 6. And then efficiency formula, IDC divided by IAC whole square into 100, 80% you are going to get in the center tapped rectifier. Now I am going to connect the capacitor, that is nothing but with filter. I am going to connect capacitor across the load resistor, Now I am going to check the output. It shows DC voltage, filtered output. The output voltage is 8.14. Compared to previous output, it will going to give more output voltage DC. Now for this reading we need to calculate efficiency and ripple factor like this. Same formulas, you need to substitute the values and get the answer. Thank you so much.